Hello, I'm Leonardo, and today I'll be talking about ChatKG, visualizing temporal patterns as knowledge graph. ChatKG is a way to use patterns found throughout temporal data to create a knowledge graph structure, which can be used then in visualization for analysis of the data through the relationship between patterns. Additionally, explanations regarding the patterns are also extracted from ChatGPT so that users don't just analyze the connections between the data, but also verify what the data is about. Visualization of temporal data, like Gapminder, allows users to find patterns of interest within the data. Here, Hans Rosling, the creator of Gapminder, shows how to use a bubble chart for in this example to analyze the correlation between lifespan and income throughout the countries of the world. And it's important to notice that here the data expert is Hans Rosler. So without the explanation that he says in the video, it's hard to understand why the patterns that he talks about exist. In the literature and also in commercial software, the most common way to demonstrate and also to visualize temporal data is through line charts, being Power BI, Tableau, and also Gapminder. Most of them, if not all, suggest and by default use line charts to show temporal data. However, even if you look at a temporal data through a line chart, how can you understand or discover why something is as it is? For instance, you can notice patterns within the data by finding valleys or peaks, for instance, in the line chart. But what does the pattern mean? Well, through the visualization itself, you can notice that maybe the pattern is related to the XY axis. For instance, this is related to the life expectancy of the United States. But which time period? You can also take a look on the x-axis and find what is the time period, and maybe you can also extract information of the pattern shape. For instance, this is something that is a decrease, is a valley going down. Maybe you can then Google or ask someone about this. But without Hans Rosling, it's hard to actually be sure of the answer, even though, let's say, ChatGPT is also not entirely trustworthy. It's certainly more than just the visualization itself. So with ChatKG, we use the information that we collected so far and ask for an explanation or some related information. So from the existing data, we have the dataset name, the country, the time period of the pattern. The pattern itself perhaps is a valley, a peak, or something else. In our case, we'll only be using these two. And the explanation of ChatGPT. And it's important to notice that here, how can I then relate two patterns? In the sense that, say I have two different patterns, can I visualize the relationship between the two so that I can find similar patterns given the first one through analysis? From existing works, we can see that the first two, dataset and country, which are categorical, we know how to use ways to correlate them to another pattern and create relationships from them. However, how can I visualize that, including the information of temporal data, which is the time period, the pattern shape, which will become categorical, but will need some kind of oracle to transform from a shape to something else that you can use, and also be able to see the explanation, which is a text. Introducing ChatKG, a novel visualization strategy that allows users to do exploratory data analysis of a knowledge graph, which associates the information of the pattern being dataset, country, and also the time period, including the ability of extracting from ChatGPT related information about said pattern. With ChatKG, users are able to model and then visualize the relationship between different patterns of a temporal dataset through knowledge graphs. For this, ChatKG defines an ontology in which it specifies the relationship between different patterns through its data. As you can see here, the main nodes of this ontology are the dataset and the country, which are both categorical, the time period, which is then split between time span and time, the pattern, which will be detected through an oracle, transforming the pattern into either a peak or a valley, and the explanation, which is the result of a query to ChatGPT. As a use case, we'll be using the life expectancy dataset from the United Nations, though this could also be changed. The process of ChatKG is to first detect the patterns of the entire data, then query the information from said patterns to ChatGPT to create a database of textual explanations, structure the existing data then into a knowledge graph, and then allow the user to visualize and explore. First, for the detection, ChatKG uses the metadata information of the dataset, such as country and dataset in this case, which are life expectancy in United States. In this specific example, you can see. And then ChatKG applies an oracle. This oracle focuses on detecting the peaks and valleys throughout the data, and also figuring out what is the width and height of each peak and valley. By multiplying width by height of each peak and valley and adding them up using this formula, we are able to discover whether or not the time period between the leftmost point and the rightmost point of this graph you're looking at is actually a peak or a valley or neither. By using this oracle, for instance, the leftmost valley is able to be detected as a valley between 1860 and 1868. However, by default, this oracle generates more than 4,000 patterns, which at the time of writing was a problem because ChatGPT didn't have an API as of yet, and ChatGPT version 4 wasn't released. Even though now this wouldn't be a problem, at the time what we did was we limited the amount of patterns by only patterns that had between 3 and 8 years of width, and if two patterns had more than 2/3 of overlap, only the bigger pattern was kept. This reduced the amount of patterns to 661. By querying ChatGPT with the template you're seeing now, what impacted the dataset name of country name between starting and end year, we were able to extract relevant information from ChatGPT for users to also take a look. For instance, in that specific example, the template would become what impacted the life expectancy of United States between 1860 and 1867. This allowed us to generate a very large knowledge graph, but by default, knowledge graph in a node link based visualization is unpractical. Here you can see two and only two countries being related by the years that they had similar patterns. I'm not even showing here the text, neither the knowledge itself, is just the time spans and time itself, which relates to different countries. And this already was too much to visualize. But here you can see in pink the two different countries, in green the time spans, in red the years that relates the two, and using the knowledge graph, you're able to apply different algorithms even outside visualization. Say you can try to identify what are the number of years which overlap different patterns, or what is the overlap between two specific countries or two specific data sets, for instance. But in our case, we wanted to allow the user to explore the data through the relationship. So we needed to visualize the knowledge graph. And this is why we propose ChatKG in a way that the different patterns are vertically aligned to this Gantt chart inspired bars, which are populated going down while the user analyzes and explores the data. By also hovering over the patterns themselves, users can also read to the right the text extracted from ChatGPT. And the patterns themselves are also clearly indicated by either an orange hue when are valleys or a purple hue when they are peaks. When the user finds a pattern of interest that they want to discover other countries or other data sets that also contain patterns in the same time period, they can click the pattern of interest, and different datasets or countries will be listed below as nodes. By hovering over and clicking in one of the nodes of interest, the user will be able to see below the patterns of that specific country or dataset. In the example shown above, 7 patterns were detected from Algeria's life expectancy. The 4 orange ones are valleys and the 3 purple ones are peaks. By hovering each pattern, we see related data from ChatGPT. For instance, it seems that the Algerian life expectancy between 1844 and 1851 was marked by French settlement policies and cholera. We also see that the period between 1863 and 1870 are also marked by French settlement policies and diseases, but with the additional issue of droughts and crop failures. By clicking in any of the patterns, ChatKG expands to show all other related countries which also had a pattern detected within the same time period of the selected pattern. Our tests with students and staff and an interview with a historian show that ChatKG is well suited for analysis of temporal patterns and their related knowledge when applied to history studies.